All right, this is chapter 4. Let me put this tape on the front of the microphone. This is the TCPIP protocols. Okay, we've actually talked about some of these already. Some of that were on the assignment I gave you all. I helped you and I gave you the hints. Okay. All right, so let's talk about it. TCPIP is what's called a protocol suite. Okay, it is a collection of protocols. TCP, UDP, ARP, HTTP, there's lots of protocols built in. So it's a protocol suite developed way back when in the 60s by ARPANET. Y'all know what the internet was really made for? Anyone know? It was originally DARPA, it was the military. It was a way of having redundant communications. Then they got some educational institutions involved, and then everybody else got on it. So, all right. So it's been around for a while. Okay. Advantages of it. It's open nature. It's free. You can just use it. You don't have to pay for it. Okay? Which is kind of good. Flexible. Runs on anything. It wasn't as easy to use initially. If you had anything to do with the internet, way back in the 90s, it was actually very hard to configure. We used something called SLIP and PPP. SLIP, Serial Line Interface Protocol, or Point-to-Point Protocol. So it was very hard to configure back then. Okay? But runs on anything. Connects dissimilar operating systems. So we have Windows connect to Macintosh, to Linux, to our phones, to whatever. Anybody going to stay in line and get the phone tomorrow?
My trip is he's standing in line at 3 in the morning.
Last 2 times I stood in line, I was the first one in line. But
so you camped out.
yeah, it was fun.
You guys are insane.
It was exciting.
At least it's a nice time to camp out.
Yeah, it's nice and cool, yes. Okay. So it says transmissions carry network addressing suitable for large networks, suitable for everything. Small networks, suitable for anything nowadays. Okay. All right, 4 layers. So instead of the 7 layers we talked about in the OSI model, we really only have 4. Application, transport, internet, and the network access with a link layer. Those are the 4 layers. What they did is said, some of these top layers like application, presentation, put them all together. So that's what they did. Okay. All right. So here we go. Here's our OSI model. Here's our TCP model. They combined a lot of them. Okay. Because really these protocols, like our web browser, HTTP, that's our web browser, doesn't it handle pretty much, it is the application. It presents it to us and makes a connection. So that one application is actually doing all of that. So they said, you know what, that's really all the application. Then we get transport, internet, and then we have the network access, which is the lower portion of it. Okay, so it's just how it's been redesigned a little bit. Okay. All right, so it's a suite sub-protocols. There's a bunch of other protocols involved. We're going to talk about a lot of those. Okay, they operate in the transport layer, no biggie there. They give us basic services, and the most significant we have in there is TCP and IP. Okay, TCP stands for anybody?
Transport.
Transmission.
Transmission control.
Transmission Control Protocol, and Internet Protocol. So TCP IP. Okay. But that's not the only ones out there. So TCP IP, Transmissions Control Protocol, Internet Protocol are the 2 most popular. Okay? All right. I'll say it's not transport layer, it's Transmission Control Protocol. Okay, it does take place at the transport layer, provides reliable services. Basically, it makes sure our stuff gets there. With TCP, we make initial connection. We do that 3-way handshake. We make a connection. We make sure it gets there. We're going to talk about UDP, which is the opposite. So it's what's called a connection-oriented protocol. You dial up the person on the other end. You connect with them first, and then you start transmitting. You don't just start sending out data. So we establish a connection. Okay. We have sequences and checksums, which we'll see a picture of in a second. Okay. Gives us flow control. Flow control is like how much data can it handle. Can you handle more? Can you handle less? Okay. Supports fragmentation. Okay, we'll talk more about that. It encapsulates them, okay, and basically we get the data packet. Okay. All right, here we go. Here's our TCP segment. We got a source port and destination port. Where'd it come from? Where's it going to? Port-wise. Then we got the sequence number and the acknowledgement number. We're going to see those in a second. It's examples of those. We got the length. Got some reserved area, which never did get used. Got a bunch of flags, urgent, acknowledgement, push, reset, SYN or FIN, or finish, okay? We have a sliding window size, in other words, how much data are we carrying? There's our checksummers, our error checking information. Okay. Then we got our urgent pointer, which of it is urgent, but doesn't do much with that. We got some options, padding, and then a bunch of data. So that's pretty much what every single packet on the internet has in it. There's a lot of stuff. It tells all the different components about it. You can see what they all are, like the flags we actually looked in Wireshark. We looked at some of the flags and stuff like that. But this does go into great gory detail. We're not going to go into that much on it. All right. Here's some of the flags right here. You can see there was acknowledgement. Then we all look at some SYN, some acknowledgement and stuff like that. These are the different things that are set so we know what the packets are doing. Here's our source port and our destination port. Remember, it's stored in, what is it stored in? What numbering system?
Hexadecimal.
It's transmitted in binary, but it's actually stored in hexadecimal. We're actually viewing it in hexadecimal. So 80 is not really 80. Okay? Whatever comes out to, I don't know offhand. But, okay? That's pretty much what the segment looks like. Okay? All right. So it says there's 3 segments. They establish a connection. They each is a message, a SYN. In other words, hey, Danny, I want to talk to you. That would be the SYN message. Okay? It has a randomized sequence number. So I'm going to randomly pick a number, attach it to a message, send it to Daniel, and say, I want to talk to you. Okay? And Daniel receives it. Okay? He sends an acknowledgement back, okay, with a sequence number +1. Okay? Then he also comes up with a random number and sends me a SYN message. All right, Ken, I want to talk to you too. So he answers my request and says, I want to talk to you as well. So that's part 2. Then part 3 acknowledges his SYN. Then I say, okay, fine, let's start talking now. Okay? And then the fin is done. We're finished. We send a fin, we're finished. Okay? All right, so here we go. Computer A to computer 1, we make a request for connection. The SYN flag gets set. We pick a random number. Okay? So this is me. I'm A, Daniel's B. Okay? So I send a SYN message. Computer B, which would be Daniel over there, sends a response, a SYN ACK. Okay? You see the sequence number here with the ACK acknowledgement has been incremented by 1. Okay? Then he sends me a sequence number, which is a random 32-bit number. Then I get back down here, okay, and I increment that by 1. And that's basically the same number. I'm acknowledging his number, but I'm incrementing that by 1. So the numbers will keep incrementing. Then with every packet from that point on, it goes up by 1 every time. Okay? All right, UDP, User Datagram Protocol. Okay? Still used today, but not nearly as much. It used to be used more. Okay? Transport layer provides unreliable data delivery. It's kind of like the mail that goes to rural route, whatever. Do they really know if it makes it to your house? Well, it's like what's the stupid one I get all the time? The buyer's guide. You want to get that delivered on your thing? I never even open it, but they keep giving me the darn thing.
Because you don't get the paper, that's why they give it to you.
Driving me crazy. Heck, I signed up for the paper for 6 months. I got it for like a year and a half. They kept sending me a bill. I'm like, dude, I signed up specifically for 6 months. You just keep delivering shit to me, you know? It's crazy. All right. So, UDP is a connectionless transport service. So we don't do that whole 3-way handshake. No assurance it ever got there. Okay. No guarantee packets received. Okay. No error checking, no sequencing. I just start pouring data at him. Okay. It lacks sophistication. Yay. But why the heck would it be more efficient than TCP?
Faster.
It's faster because we're not having to make that 3-way connection. We're not having to do sequence numbers. I'm just start dumping stuff on it.
I mean,
Okay.
with the speeds of the internet nowadays, it's kind of like...
Yeah, you really...
It's kind of a waste of bandwidth. Then.
Right, yeah. So, all right. So, there are useful, great volumes of data transferred quickly. But really, this isn't used that much anymore because with the speeds of the internet, TCP is just about as fast now, and now we know we're getting it. So, all right. The header is a little bit shorter. You got the source and destination port, the length and the checksum. We still want to know that the packet made it. Then we got the data. We're missing all the rest of that stuff. We're missing all the flags, the sequence numbers, all that stuff. Okay. All right, IP. Okay. IP, it says how and where data delivered included in the source and destination address. It's kind of like if I take an envelope and put the correct address on it. That's IP. The delivery service to get it there, the postal service, is TCP. Okay? So it's up to the postal service to get it there. It's up to me to put the correct address on it. So this is the actual address on the envelope. Okay? It says it enables TCP for internetworking. It says traverse more than one LAN segment, more than one network through routers. Basically, you can talk anywhere with this. Okay? We have packets. We have a data envelope. Contains all the information about the routers, about where they're going, about the segments. Okay, and we'll talk more about that as well. Okay? 2 versions, 4 and 6. 4 is unreliable connectionless protocol. It's old. It's really, really old. Okay? All right. 6, newer. The next generation. Yay. Okay, released in 1998. Advantages. Billions of additional addresses. Okay? And better security and prioritization provisions. With IPv6, if everybody on the world wanted an IP address, and if we could use all the numbers, we'd each get about 0.6 of one. Not quite enough for everybody.
Replacing the 7?
IP6 is replacing 4. IP6 is what we're switching to. It's been out for a while, we just haven't implemented it yet.
Oh.
Okay. So even though it says it came out in 98, it was one of those deals, just haven't implemented it yet.
Looks like the government.
Right. IPv6, every person on Earth can have 50 octillion addresses. That's like million, billion, trillion, 5 other numbers than octillion. So that you can have a number on every blade of grass, every speck of dust in your house. I don't know.
Might need it in the news.
Yeah, we might. That's a lot of. Did they go overkill? What do you think?
I don't think so.
I don't know, everything is...
They said we would never run out of IPv4 addresses.
Right, and 640K of memory was plenty way back when. You know, it's one of those deals like. What do you? I think it's
all these
good.
damn handheld devices that come out, you're gonna need it.
That's right. Everything can have one. All right. They really don't go too much into IPv6. They go a little bit, but okay. So here's our IPv4. We talked about some of this already, but we got the version, the header length, the total length identification. We got our time to live. We talked about that. That's the thing that decrements with every router. Did I talk about that already? I think I did a little bit. So every time it goes through a router, it gets decremented. Okay. We have the source and destination. We got a couple other things, but that's IPv4. Here's IPv6. Okay. Version, traffic, flow label, payload link, next header, hop limit, source address. Look how big these addresses are now. Why are they so big? I mean, compare them. See how small that is? See how big that is? So we're going from 32-bit to 128-bit addresses. So they're huge. Okay. So there's a lot more there. And some of the stuff's been removed. Like checksum's been removed. Did I already mention that? Yeah, I think I already meant. If I didn't, why do you think they would remove? What checksum is error checking information. So why did we remove it?
Isn't IPv6 more reliable anyways?
It's more reliable, but every time it went through a router on IPv4, every time it went through a router, the checksum had to be updated.
Oh, that slows it down.
So basically, the header was being checksummed and the entire packet was being checksummed. Because every time you go through a router, we're replacing where it's going because it's to the next router. So basically, we're performing checksums twice with every hop. With IPv6, this is, since we're changing the header, why not we just do the entire packet? So that's what they do. Makes sense. And I have a presentation just on IPv6 which I can show you. Okay? All right, IGMP, Internet Group Messaging Protocol. Operates at the network layer. Multicasting stuff like what multicasting is. If I want to image this room with all new OS, I can use multicast and send it out one time to everybody. It's kind of like a broadcast, but certain people would listen in on it. So I don't have to send it out 2 gigs and 2 gigs and 2 gigs and 2 gigs. I send it out one time. That's what a lot of streaming services do. Can you imagine if Netflix actually made a direct connection to every user and didn't do any type of buffering or anything? That's odd. Okay, so multicast and point to multi-point transmissions. Okay, one node sends data to a group of nodes used for internet teleconferencing, video streaming of stuff, imaging of machines. It's used for a lot. Okay. ARP, Address Resolution Protocol. We talked about this already. It's a network layer. It uses IPv4. There is also ARP for IPv6. It's the MAC address or the machine address to IP address is what it does. Okay. It maps the MACs to the IPs. Right? Has an ARP table. How do we check it?
ARP-space-A.
ARP-A shows us our table. Gives us MAC to IP address, but it's internal only. So if I want to find the address of Zombocom, I'm not going to find it in my ARP table, but I will find the gateway. Because if I want to go to Zombocom or Google or anyone, if it's not in here, I send it to the gateway, and then the gateway sends it out. So with ARP, I only know how to get to the gateway. Okay? All right. ICMP, Internet Controlled Messaging Protocol, is used with ping and traceroute, stuff like that. It's network layer. It says reports on data delivery, success or failure. Did it get there or not? That's what we did. Ping in here, didn't we? I think we did. We ping some address and it comes back and says successful or not.
Ping Zombone and said we're awesome.
Ping what?
Ping Zombone and said it was awesome.
Oh, there. Yeah, it was awesome. You couldn't do anything in Zombocom. Yeah, they don't go show that to your kids yet. Guarantee they'll watch it for hours. All right. Okay, works for network congestion, fails at destination. TTL expired is how traceroute works. Okay. Cannot correct errors. It really just tells you about them. Doesn't fix anything. Okay. Tells you what's wrong so you can fix it. Okay. All right. There's IP or ICMPv6 for IPv6. Okay. IP4 addressing. Okay, we have two types of addresses. A logical and a physical. The physical is our MAC address. That's the address assigned to our network card. Everybody should have a different physical address. The logical is the IP address that we assign, automatically or by hand. And those are given out. We use them. Okay. Logical changes. Physical never changes. What's that on my eye? All right. IP protocol handles it. Handles the logical addressing for us. Okay. Has a unique 32-bit number broken into 4 octets, 8 bits each. Okay, here's an example. Yeah, and when I had you guys write down the IP address to certain places, man, some of you really had a hard time doing that. Some of you put multiple periods, you reverse the numbers. It was like, ay, ay, ay. I was a little bit lenient on that. But okay, so it's divided into 4 octets. Here's an example. Okay, we have the network class is determined by the first octet, which is not really used anymore. Okay, A, B, and C. A is for very large networks. So give me an example of a large network.
Google.
Actually, I don't know how big Google is.
The Pentagon.
Actually, one of the biggest ones was like Hertz. Hertz is a nationwide company. A lot of people think, oh, military. Oh, no, military's not that big. Military is actually Class B. Okay. So a Class A network can have 16 million hosts per network, but a small number of networks. There's only a few of them, but they're huge. Class B networks, we have 16,000 or so, and they're pretty large, 65,000 each. So you think of military bases. You think Tinker's got more than 65,000 stuff? Well, actually, they use internal addressing now, so it's all different. But, you know,
We're pushing 87,000.
yeah, it's changed the way it all works now that we have internal addressing. But Class C, 2 million of those networks out there, and those are small. So I ran an ISP, Internet Service Provider. I gave out, I did email and hosting and stuff like that. I had 128 addresses. So what type of network did I have? I actually had an A. So the problem is, this was a great idea. Failed miserably. Because like, you know what, we got a lot more than 2 million networks out there. Small network. So what happened is that Cox was my provider. So Cox was a very large network. So the first octet was 66. That's how you can tell which type of network you're in. Look at the very first number. Mine's 66, okay? But I wasn't a big network, but Cox was. So what happened was Cox had the network, and I was buying a little piece of it from them. So what ends up happening, initially when it was done, Cox would get their network, and it was theirs. Everybody else had to get their own, but they said, you know what? We only got 126. Worldwide, is that enough? No, it's not. So they started breaking those apart and subnetting them out. So Cox gave me a very small portion of theirs. Even at your house now, there's one little teeny tiny portion for yourself. Okay? So Rose State's 164, first octet. So what type of network is that?
B.
That's a B. And that we get that from OneNet, our provider. So 65,000 might be all right. Because at Rose State, what do we have, like 5 addresses? That's all we use. One address to surf the web. That's it. One address for the wireless. So there's very small amounts of numbers. Actually, we have more than that. But they gave me 32 all by myself. But, you know, it's just that this was a great idea initially. Did you ever do something and like, damn it, that sucks, I should have done something different? It's kind of what IPv4 was. All right, it's working, but we got some problems. You ever do that? Way back before we had D2L and WebCT and all that, before we had anything, I actually wrote my own online software. You could check your grades, I could do attendance, you could do quizzes and everything on it. I think I designed it 3 times. First time I did it, didn't really think it through really well. Darn, I was an idiot. So I redesigned it, rewrote it all. Second time, I'm like, damn it, that sucks too. So I didn't redo it a third time. It's one of those things, you know, what's that saying? Those who failed to plan to fail or something. You know, that was kind of me. But so after the third iteration, it was actually working quite well. But then WebCT and everything else started coming out, and we started using other stuff. But it's kind of funny when I first did it. Everybody's like, "Why would you want something like that?" Students could check their grades, they could do homework, and it was like, it was amazing. Because I would teach at Park University, and my students were submitting comments. Say, wow, can do is get this grading system where I can do his quizzes online and check my grades anytime. I wish the entire campus was it. I was getting phone calls from the main campus. What are you doing? That's what do you mean? We're reading your reviews. And one student said, the only thing he's missing is popcorn or something. I was like, what? He says, best class I've ever had. He's giving me access to my grades at home and all this stuff. And I'm like, how are you doing that? But I actually had some people from Park University who were starting to use it. It was kind of funny. But then we came out with other systems. But, you know, the point is, this was a great idea, but the idea has passed. We're moving on. Okay. All right. We also have D and E. Okay. D is multicast. E is experimental. Okay. So of that 32-bit address, you really couldn't use all of them anyway. Okay. Says networks used between 1 to 254. We're not going to cover the binary in this chapter because it talks about it a little bit, but it talks about a whole bunch more in chapter 10. Actually, I think I might want to cover chapter 10 next. I'll let you know next class period. We're going to cover 5 or 10. Because 10 is more of the same stuff. That's why I usually like to cover that one next. Okay? Can't use 0, can't use 255, but we'll cover more about that. You can't use all of the addresses. Kind of sucks. Okay? Class A devices share the first octet, 0 through 7. Which is network ID, then the host is everything else. So the Class A network, the first octet, the first 8 bits are the network ID. Then the rest of the host. Class B network, the first 2 octets are your network ID. All the rest are your host. Class C network, the first 3 octets are your network ID, and the last one is your host. We will get into all this in great detail when we get into that area, but this chapter doesn't cover it enough. Okay? So, what we're basically saying is out of the entire 32 bits of available space on IPv4, with A, the first part's the network, then the rest is the host. B, and then C. Okay? Pretty much how it works. Okay? We have a loopback address, 127.0.0.1. That's you. Okay? That is your machine. If you ever type that in, it'll go right to yourself. So it's actually very good for testing purposes. What happens is it actually goes down the network card, back up the network card. So if you want to test anything, it's a great way of doing it. Okay? It's an attempt to connect your own machine. Great for troubleshooting. Okay? ipconfig, we've actually looked at these commands on Windows. In Linux, it's IF for interface configuration. Okay? So a little bit different. IP configuration or interface configuration. What?
So you could type in ipconfig and that address will do a loop test on your machine?
No. If you just type ping 127.0.0.1 or something, that'll be a test. Now, what it's saying is 127.0.0.1 is your address. Okay, so no matter what your regular IP address is, that's also your address. If you were to type that in your address bar, it would basically go to yourself. So if you're running a web server, you can see it or something like that. So, all right, binary and dotted decimal. Okay, says dotted decimal says common way of expressing IP addresses. That's like the 66.210. Whatever. 164.58. Whatever, or the 10.10 or whatever. That's what we see it in, okay? A period separates each decimal, okay? Okay? They also had binary equivalent, which we will do, okay? Convert each octet, remove the decimal points. And we'll see how that works, okay? But they just don't go into depth here. Then a subnet mask. Those of you who did the assignment, actually quite a few got that wrong, by the way. It was actually 255.255.00. A lot of people put 255.255.255.0. That's what your home one is. Okay. Subnet mask is like the city. If I told you I lived at 8412 Tree Line Drive, could you find that address? If you did not know I lived in Choctaw, or I lived in Oklahoma, you might, who knows where you're going to end up. Okay. There's actually quite a few 8412 Tree Line Drives. An easy way to see, go on Google Maps, type in like your number, then your name of your street, it always shows like a whole pile of addresses. Then once you start typing the city, it narrows it down. But the subnet mask is like the city. Okay. Right. It's a 32-bit number. It tells it which part is the host and which part is the network. We'll see exactly how that works. Okay. Informs about the network segment. Okay. There's four octets. Again, the same 32-bit. They can either be, well, there's certain values they can be. Okay. Normally assigned automatically unless you do them manually. And we will go through this in great detail. Class A network is that. Basically, the 255s identify the network. 255, if you don't know that in binary, it's all ones. 8 ones. So, with 255, it's all ones. 0 is obviously all zeros. So, all the ones identify the network. So, in a class B, it's 8 ones and 8 ones. So there's 16 ones. That identifies the network as the first 2 bits, or 2 octets. Then class C, it's the first 3 octets. So the ones are the network, the zeros are the host. Okay, we'll go into great depth on that. Promise you. They just don't do it in this chapter. All right, IPv6, this book sucks. Okay? There's 2 slides on it. Okay? 128-bit addressing. It's huge. Okay? There's 8 16-bit fields. So IPv4, we had 4 8-bit fields. Now we have 8 16-bits, so it's quite huge. Okay? Normally shown in hexadecimal separated by colons, so this is what they look like. You can abbreviate them, so I could actually abbreviate this as FE22 colon 00FF colon 002D colon 3012 colon CC3E3. What happens is if you put 2 colons next to each other, what that means is it's a bunch of zeros. There's 8 sections, 1, 2, 3, 4, 5, 6, 7, 8. So if I was to redo this with these 3 sections and these 2, that's 5. So you see there's 3 zeros then? So if I just put 2 colons in the middle, that means 3 zeros. It's not, I do have a better presentation on this, which explains it better. We'll look at that. But you can put, instead of 00FF, you could just put FF. Okay? All zeros can be just 0. It's kind of like, if I was going to give you $1, that's 100. But 0100 is the same, isn't it? If I give you, it's like you can put as many zeros at the beginning if you want, but you don't need to. Okay. There's a multicast address is used for transmitting data to many different devices, basically the same as IPv4. Okay. There's an anycast which go to anyone in a group. Okay. And there's all kinds of modern devices that support it. But the cool thing about it is IPv6 is 100% backwards compatible. I was reading an article on Google where someone says, oh my God, we're out of IP addresses. You must replace all your networking equipment because the new internet is IPv6 and you can't use it. Basically, if you don't upgrade your stuff, you're going to be on the old internet and that's it. I'm like, no, you're an idiot. I think that was the only time I've actually replied to a news article saying, oh my God. Who wrote? Did you all see the Fox News article about the iPhone 5? Well, about a year ago, there was a spoof of the next iPhone coming out. Oh, it was really super. It was like paper thin. It had a laser keyboard, holographic projection screen, and everything. Fox News was interviewing the people waiting in line for the iPhone 5. The guy says, oh yeah, it's going to be the best phone ever. It has all these features. Then Fox cuts to that video. Yes, it has a laser screen, a holographic projection system, and everything. You're like, oh my God.
That's Fox.
Yeah, it's Fox News. It's pretty hilarious. But no, that news article basically says they don't work together. They do. They work 100%. We are already on IPv6. There's Horizon Electric, I think is the address. Hold on. Let me check. Where's my map? There. Maybe? Come on. Internet died. No, that's not it. Hold on.
Earthlink.
Oh. Is it Horizon Electric? No. Can't think of it. Something close to that. But you can basically get an IP. They're a IPv6 tunnel provider. You get an IPv6 for free. You can go there and it'll be yours forever. And you can actually program it into your router if it supports it. So it's where you can start testing. It's Hurricane Electric. We're gonna find it. There it is. Hurricane Electric. Hurricane Electric. I have no idea why they got that name. But Hurricane Electric, they're an IPv6 tunnel provider. You get free IPv6 certificates, free addresses, and somewhere on here apply for it. Tunnel Broker, there it is. Our free Tunnel Broker service enables you to reach the IPv6 internet by tunneling over existing IPv4 connections. So, Hurricane Electric is the place. So if you're interested in starting to play with this stuff, it's kind of cool. I do have a whole nother presentation on IPv6, which we'll cover, just not today. Okay? All right. Assigning IP addresses. Okay? It says the government gives them out. It's ICANN or IANA. They give out the addresses. What happens is countries would contact them and say, we need some addresses. Well, we ran out about a year and a half, maybe 2 years ago now. The last group of addresses were given out. There are no more. So what do we do now? Well, now we have to convert to IPv6. We no longer have a choice. But does that mean there's not addresses out there? No, that means the country, whatever, got their supply, but once they run out of that, then they have to start going IPv6. But there's going to be plenty. Okay? So companies get them from our ISPs. The ISPs get them from the governments. Okay? It says each network node must have a unique IP address. So your house has a unique address. Row State has a unique address. But internal to Row State, we have a different address. We have an internal number. So Row State internal and OKCCC's internal could all be the same. We use 1010 here. A lot of places use 1010. No, do we use 1010? Yeah, we do. We use 1010. Okay, and a lot of us at a house, so we have 192.168 and our routers at home. That's what pretty much everybody has. So how is that possible? Well, because it's internal, because we all have a different external address. Okay? If you have the same address, you're going to get an issue. Okay? We can assign them manually what's called static IP addressing. I could go to each machine and manually give one. I did that for years. When I was a tinker working in the network shop, we had to go to every computer and give an IP address. And I was like, why are we doing this? I said, why don't we use DHCP? Oh, no, we can't do that. Can't do that. So we did them all manually, all 1,500 computers in AOS. Then they changed. We got to do them again. I'm like, dude, why don't we use DHCP? We can't, because certain machines have to have certain addresses. I'm like, yeah, it's called a reservation. Oh, no, that won't work. I'm like, a bunch of idiots. And the worst part about it was we'd go and do it manually, but you ever been deployed in the military? What sucks is the guys that are deployed, they're not there, so you can't give them an address, and they come back 3 months later, and their machine doesn't work because no one was there to give them an address, or they had their laptop with them, and can you imagine the typos we had? I mean, 1,500 addresses entered manually. I have a hard time entering 5 addresses manually. So, a lot of issues. Human error. Okay, a lot of work. Now, our servers, on the other hand, those are usually configured manually. You can still do them automatically, but they're usually done manually. Okay, or you could also do it dynamically, which I was talking about. Assign them automatically. It's the most common method. Can you imagine your house if you had to have a manually assigned IP address? That's what it used to be when the internet first came out with SLIP, Serial Line Interface Protocol. You had a specific manually assigned IP address for your house. And the ISP either had to come out and do it for you or walk you through it. And I remember walking so many people through it, setting those things up, and it was tough. Now it's all done automatic. All right. DHCP, Dynamic Host Configuration Protocol, automatically assigns an address uniquely to every machine. It's kind of funny when when DHCP first came out, the release one of it basically, it would give out addresses, but it never checked if they were already in use. So say I'm giving out 10.10.0 something, but Daniel over there manually assigned himself one 10.10.05. So I start giving out addresses. I give out 1, 2, 3, 4, 5, 6, 7. I didn't check if they were in use. So what ends up happening is you had to put an inclusion in there because it didn't bother. It just gave them out, and you had so many issues with it. Version 2, it started checking. Tried to see if the address was in use before it gave it out, which is kind of a nice thing to do. Application layer, reasons for implementing. Reduce time and planning. I can configure a DHCP server in seconds and give out millions of addresses. Super easy to do. Okay. Reduces potential for errors. Yeah, if I screw it up, yeah, it's going to affect everybody, but at least I'm only entering in one place. If I screw it up, I can fix it in that one place. Okay. Enables users to move workstations and printers. You can take it, plug it in somewhere else, and automatically get an address. Take your laptop. Can you imagine if you had to manually configure your laptop every time you went somewhere to a hotel? I can just see the hotel clerks. Okay, sir, here's your IP address. Ain't no way people could figure that stuff out. It's impossible.
They have VoIP phones that are manually configured all on the base. The
Yep.
VoIP phones, they're all manually configured.
Main? Our VoIP phones are all automatic. All we do is we tell them the MAC address of the phone we have, and instantly sends the data to it. It's all reconfigured with everything. So they really do it manually, huh?
That
What?
way they can control where they're at.
Aren't they separate though? The VoIP? Are the VoIP separate?
Wow,
That's
it's- yeah,
separate connection.
but still controlling where they're at. Well, see, the one thing good about our phones at Rose State, I could unplug this phone right here, plug my office phone in. Now my office number would ring here.
Well, that's what they're trying to control because
They don't want that to happen.
because stuff walks off.
Everyone ever had Vonage? I had Vonage. It was amazing. Back when I had my ISP, heck, I had a super fast internet. Why not have it? I had Vonage, and a good friend of mine who used to own another ISP, he had Vonage as well. He moved to Mexico. Still lives at Costa Maya, Mexico right now. He took his Vonage thing with him to Mexico. You dial his same Oklahoma City number, it rings in Mexico, free of charge. So it's awesome. I mean, you can take it anywhere. You go to Australia, plug it in. Your Oklahoma number will ring in Australia. So if you got relatives out of state, out of country, hell, just get a device here and mail it to them. Then call the local number. It's free. So it's a lot of people. Vonage and all of them say they charge for international calls. Yeah, if you dial an international number, but if you take a Vonage device and mail it to them in China, it's not international. It's local. You dial a local number, and it's free, unlimited. So it's kind of crazy. Okay, so it enables people to move around. Okay, makes IP addressing transparent for mobile users. Can you imagine if your cell phone, you had to manually configure it? Every time you hit a different type of cell tower? Oh, that'd really suck. That'd be terrible. All right, there's a lease process. You borrow it or lease the address while you're attached. The lease could be from minutes to unlimited. I don't ever recommend giving out unlimited. I did once. And I gave it out at Chapel Supply. The way the lease process works, I give you an address. After a certain period of time, you ask if you can keep it. Okay? But what happens if I give you an unlimited address? You're never, ever going to ask me if you can keep it. Because you think you're going to keep it for life. So what happens if I ever want to change it again? I have to go to every machine because Daniel over there thinks he's got it for life. He's never, ever going to talk to me again. So when we had one set up that way, then we had to change some stuff. I had to go to every darn PC, release the address, renew it, because the machines were set up to just keep them for life. And it was like, oh, that sucks. So I will never, ever give out an unlimited again. Okay. The lease duration is to determine when you attain an IP address. You connect to the server, and the server tells you how long to keep it. You can also force it with release and renew. Okay. The configuration says specify the least address range. On the server, I go in there and say, give out these addresses from 1 to 50. And like at your home, you always give out 1 to 100, I think, in your Linksys router. Okay. You can give out more if you want. You can configure the duration. You could, again, make it unlimited, but I don't recommend it. Okay. And there's several steps to negotiate it, which I think they talked about here. There we go. Okay. Step 1. The client says, hey, this is client A. What address can I use? Who do you think he's asking that information of?
DHCP.
He's asking via the DHCP protocol, but who specifically is he asking it to?
DNS server.
He's actually asking it to anybody because he doesn't know. He's sending out a broadcast, hey, I need an IP address because he doesn't know anybody. He's new on the network. He doesn't know no server, so he sends out, hey, anybody out there? Okay? The server responds to that message. Hey, I got an address for you. What do you think? Okay? So it gives an offer. Discover, offer. Then the client says, hey, I'll take that address. That's the request. So we got a discover, offer, and a request. Hey, I like that address. I'll take it. Then the server says, all right, you got it. That's acknowledgement. Dora, D-O-R-A. Like Dora the Explorer. There's a movie coming. Was there a movie coming out for Dora the Explorer? I think I saw
It was
it.
a spoof.
Was it a spoof? Okay, I couldn't remember.
It was really funny.
That's right. It was pretty fun. Okay. But that's how it works. So what happens if we have more than one DHCP server? What do you think? It's actually a bad thing. Because can you imagine client A says, hey, I need an address. Who's going to answer? Both. And then what happens is they both offer, and then the client picks one and acknowledges the one he picked. The other one does time out after a while. But you really don't need more than one. Now, for a real live enterprise level network, you need 2. But you actually should only give out 70. There's a whole, the way the lease process works is, if Daniel over there is my DHCP server, and he dies, what happens? We're dead. We ain't doing nothing. So what you normally do, you configure a DHCP server, then you configure a DHCP relay agent. So what I'll do is I'll take David over there and say, David, you're a relay agent. So what David would do is David would forward the request on to Jason. All right? Got 3 names down in here. So David would forward the request on to Jason. So if Daniel wasn't answering, David would be forwarding the request on to Jason, and Jason could be remotely assigning them for us. Okay, kind of a good way to do it. It's the way you really should do it in the real world. So, and it really doesn't go into that here. I cover that more in the Advanced Networking Concepts class. But so that's why I said these books cover this much. There's a lot more. Okay, terminating expires based on the period established, or you can manually do it with the DHCP release. Okay, circumstances requiring release. It says server fails is replaced. Okay, or server runs on several server types, installation and configuration vary. Okay, yeah. So the server fails, you might have to replace it. Okay, I think that's about as far as they go. Okay, and really doesn't talk about it in there. At least I don't think it. I'm pretty sure it doesn't. The way it actually works. Say Daniel gives me an address. Okay, say he gives me a 24-hour address. So how long do I have to keep it for? No.
20 hours.
12 hours. At the 12-hour time period, 50% of the time through, I'm going to say, hey, Daniel, this address working pretty darn good. Can I keep it? He's like, sure, keep it. Okay. 12 more hours, keep it again. So halfway through, I'm going to keep it. Okay? Well, if he doesn't answer me, so, if 12 hours through, say we just redid our network, okay? We're all running Cox in here, and he's Cox's server, and they just redid it all. So they replaced Daniel with Jason over here. So at the 12-hour point, I'm going to say, hey, Daniel, I want to keep my address. And he don't say a word. Well, I'm going to continue to function. I'm going to keep asking them until I get to 87.5%, which however many hours that turns out to be. At that point, I'm like, Daniel, you suck. I'm releasing myself and getting a new one. And at that point, I release my address. So you figure, what's that? Probably 18 hours. Probably about 20 hours. So about 20 hours into my 24 hours, I give up on Daniel. I release it myself and say, hey, can anybody else help me? At that point, Jason goes, oh yeah, I'm the new server over here, and he gives me an address. So the reason they do that If Cox wants to redo their server, they know within 1 day, everybody's going to get a new address. But do they have to contact me and tell me about it? Nope, because I'm going to do it automatically. But if they gave me an 8-day lease, I'm going to wait 4 days. Then I'm going to look for Daniel, wait 2 or 3 more days. So that's why it's important to give out short lease durations. But there's a drawback to that. You have thousands of people. Every 12 hours going to be asking Daniel for an address. So that's a lot of traffic every 12 hours. So it's kind of a toss-up. So what you could do, give it a little longer lease. Then if you're going to be doing work on the network, start shorting it. Maybe give out a 2 or 3 day lease. Then, okay, next month we're doing DHCP work, so we'll lower it down to 1 day. A couple days before you do it. And then do it. So I used to do that with DNS when we, in the other class, talk about DNS, the different settings for DNS on the retry and expired. When I knew I was going to do work on my DNS server, I'd set it to a very short expiration so my records were expired within hours. That way I can modify them. I knew that all my clients were instantly going to ask me for a new address. Then once I got them all reconfigured, then I changed the time back up again so they wouldn't bother me every 30 minutes. So a lot of good ways to do it. And most places just leave it at 24 hours because that's pretty good. They don't really go into it in the book, but it's pretty much how it works. Okay, private link local address. Private address allows hosts to communicate across an internal network. API-PA, which we'll talk about in a second, is that. Okay, cannot be routed. Okay, actually I think they talk about it. Hold on, let me check. They don't. Okay, talk about it more then. 169 address. Anyone ever seen a 169.254 address? Okay. If you unplug your network card, I actually think we had that issue when we were trying to take that quiz the other day. We all ended up with a 169.254 address. That's an automatic IP address. Okay. What happens is if you can't get one through DHCP, your machine automatically gives yourself one. It's 169.254, and the rest is all random. It's on a class-based subnet, so we're all on the same network, but we all got different host numbers. That way we can talk internal. But that's it. We can't go outside the room. We're stuck. So it's non-routable, but they do that so you can actually take 2 computers, plug them into a switch. They'll automatically get an address and talk to each other. Can't surf the internet, but at least they can talk to each other. Okay, that's automatic IP addressing. Okay, so there's a specific address for that. There's also a link local address, which is a provisional address. Kind of what they talk about the same thing, but it's also talked more about an IPv6. It's capable of data transfers only on your local network. They're only internal. Okay, it's also private or zero configuration. It says. Collection of protocols that assign link local addresses, and they did mention here. AP, automatic private IP addressing, is one of those that automatically does it for us. Okay. Services that provide link local addressing on Windows. That's the 169 address. Automatically gives it. IPv6 gives us one automatically. We get our regular address and a link local address. Where IPv4, we get our TCPIP address. And if we can't use that one, if that one goes away, then we get one of these. IPv6, you get both. Which is kind of a cool idea. Okay. Sockets and ports. It says processes assign unique port numbers. Our web browsers use port 80. Our mail uses port 25. Telnet 23. FTP is 20 and 21. So different things have different ports on them. It's kind of like TV. Channel 4 is what? Is that KFOR or something? KFOR. So we have different television stations have different numbers. Same with here. Different protocols have different numbers. Okay. It says the socket is the port number plus the IP address. So if I want to connect to a website, let me connect to one. So I'm going to connect to, let's just go to Google. I did not specify a port. So I just put the address up there. Y'all see that? Google.com is all I did. I could specify the port. I could specify port 80. I know it's hard to see, but I could specify port 80. Goes to the same place. But when I worked at the LAN shop at Tinker, it was tinker.af.mil:552. Went to the 550 seconds webpage. Or :752, which is the 750 seconds webpage. So you could actually specify different ports. Our cameras we got in here, this one, all of our cameras, at least in terms of my lab, are all on the same IP address now, but they all have a different port. This port number is 214 because it's in room 214. The one in my office is port 131. So you can very easily see different ones. Actually, I don't remember the address from in here. I thought it was Rose Cams. Can't remember what I put. Well, if I can remember the address, I can show you the camera in my office. I don't remember what it is. What? Yeah, it should be on. Let's see. I think that's what it is. Let's see. Go to 131. Yeah, the camera's up, so I know it's working. Rose cam. Try this again. Come on. That should work. Come on. I don't. Oh, because we have an internal thing. Okay. We have to remove the DNS entry for that because we have that internal, and that's an issue. But I'll try to remember to fix that for next time. Because I forgot we still have that in our DNS here. But the port number can be one of anything. Okay? There's a lot of common ports, but there's also smaller ports, which we'll see. Okay? It simplifies it. It's kind of like on your TV. You have one cable coming in, but you got a bunch of different channels on it. Same thing. We have one internet coming in, but a bunch of different channels on it. Ensures that it's transmitted correctly, and there are some examples of them. Telnet 23. There's an IPv4 address. There's an IPv4 address with a port. Alright. Alright, here we go. Actually, make sure I didn't skip one. Okay. Alright. So we can request and we get acknowledgement of port 23. We're just connecting to a telnet server. We specify 23. Means the server on the other end is answering on port 23. Okay. Sockets and ports. Okay. 65.535. Have we looked at GRC yet in this class? We need to do this. You should do this at your house. At your house, go to www.grc.com. www.grc.com. GRC. That's it. .com. Okay. Gibson Research Corporation. That's where the GRC comes from. Okay. Now go here and click on Shields Up. Right here. Then scroll way down. Find it. There it is. Shields Up. Go to Shields Up again. Go to Shields Up again. Okay. Then proceed. Alright, now I want to test common ports. What this is doing is that this is testing all the ports on my machine. Do this at your house. Here's my IP address. Whoa. Got a failure already. So I had some problems. Okay? Okay. This returns three different things. Open, closed, or stealth. Open means that door is wide open. Come on in. Closed means I know there's a door there, but the door's closed. Which is good. Stealth means I can't even tell that there's a door there. It doesn't even know we have these ports, but it knows we have that port. Okay? That's all. But do this at your house. I had one of my students years ago do this, and he called me up at home and was like, Ken, I got a problem. I'm what? Because it knows my name. I came up and said, hello, Daryl. You're running Windows 95, version whatever. You're currently using Microsoft Office editing such and such a document. He's like, what's going on? He didn't have no firewall, nothing. The cool thing is if you do this with your firewall, then if you know how at your house and you want and can plug your computer straight into your router, into your cable modem and do it again, you'll see the difference. It's really amazing what you see. Because grc.com, it's free. Now I did common ports. You can test all of them if you want. Yes, sir.
If I'm running like Norton 360, is it gonna like block that?
It won't block it, but it'll all come up as stealth.
Okay.
What this is trying to do, we told his website to try to get into us.
Okay.
So it tried all these ports, and it's like, nope, 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 nope. So that's what you want. You want stealth. But if it's misconfigured, it could come up and say, hey, you got an open port, whatever. Now, having an open port is not necessarily bad. If I'm running a web server, obviously I have an open port. I want people to be able to connect in. If I'm a mail server, I want them to get in. So depending on what you're doing, I run this from my house, I have open ports. I have port 20 open, port 21 open, port 22 open, port 80, because I use them for things.
So in a sense, this is what kind of like all the.
These are just the common ports.
So is this what it's kind of like hackers look for when they're looking at?
Oh, yeah.
They go, oh, I can get in there.
Pretty much. Yeah, this is, and here,
Can you
It might-
manually put in an IP address?
actually not on this site, but you, Nmap, you can do the same thing with Nmap. You can tell Nmap to connect to his house and try every port. All this is the internet version of Nmap. Okay. But with this here, it's closed. So is that a problem? Well, the door might be shut, but at least now I know there's a door. There's something. I mean, it's a
You can
little...
try to do like elevated privilege and open that door, right?
Right, they could try to open the door. Up here, they don't even have a clue that I got a door. Here they have a door at least. It might be shut. So having a door is not as good as stealth, but having a closed door is better than an open door. Okay, so it's grc.com, and there are ways you can run this against other people's places. I was up in teaching a class in Colorado, and I was teaching it to teachers. So I had a whole room of teachers, all from different schools. We were running Nmap against our schools. I was trying to show them the same basic thing, but doing it with Nmap. And they all came back and said, they had port 80 open. Well, duh, they all have web servers. They had port 25 open. Well, they all had mail servers, so which is the normal stuff. So I get back from Colorado. I'm sitting in my office, and I get a phone call from our VP of IT. He's like, Ken, we got a problem. I'm like, what's going on? He goes, Cameron University, I got their head of IT on the line. He says, someone from your network tried to break into their network. I'm like, what? Well, I had a guy from Cameron University in my class. And we were using our virtual labs down the hall to go out from here into the other schools. And I says, we didn't try to break into it. We just did a port scan, just like we did here. He's like, oh. And I says, I also ran one against you, John. And see, Cameron University noticed it, contacted us to say who was doing this, make sure we weren't bad guys. But our IT services didn't even realize I did it.
Would have NIDS
What?
find that, a network intrusion?
Yes, it could, yes. It's funny, he says, yep, we sure did. We ran that against that school, and I also ran one against yours. You should have seen it as well. He's like, oh, okay. I mean, we weren't doing anything bad. We were doing nothing different than you could have done at your house, which was good. So, yeah, it's a kind of a try this at your house. You might like it. All right. So, a lot of well-known ports. We talked about those. There's a lot that are for the operating system to use for administrative type stuff. There's also some upper ports that are used for other things. We'll see some of those. Okay, used for special stuff. There's also dynamic ports, or you can really use any port you want. My I showed you my thermostat and everything at home, didn't I? I use different ports. I use 21 and 22 and 8080. I use different ports because I know what they're doing. Here's a list. So 20 and 21 are normally FTP. I use them for other things. 23 is Telnet, 22 is SSH. Basically, these are important ones. Calling. He's calling me from Moore. I don't know anyone in Moore. Okay. Those, you don't need to know so much. But the most, but hang on, there are pretty much important ones. They're just ones you, over the time of learning this stuff, you should know. 3389, 443, 80, email, telnet. So just try to memorize those common ports. Okay? There were 65,000, so I'm not asking you to memorize that many. Okay. I set up the did I talk about setting up the wireless at Buffalo Wild Wings? I used to do all the wireless for Buffalo Wild Wings. But I installed it, and then I billed them a monthly fee for maintaining it. After I installed it at 4 different locations. After 2 years of not a single phone call, I stopped billing them. I felt bad. It's like I've been billing them for 2 years, never got one single phone call, so I stopped billing them. So I just couldn't keep their money. I didn't feel right. But assume they're still using it too. I don't know. But I wanted to make it so at Buffalo Wild Wings they could surf the internet and check email. So what do I owe? No, it was just surf the internet only, but check web-based email.
80.
80.
So on my routers, I configured just port 80.
Well, 80 and maybe 443.
Okay, maybe 443 so we have secure websites. That's what I did. Failed miserably. I'm like, kind of feel like an idiot. I said, I teach this stuff. Why isn't this working? So I'm surfing the internet, so I need 80. 443 for secure websites, but why isn't it working? I blocked every port except for those 2. What?
Yeah,
53. You need DNS. The way I tested it, I'm like, okay, think about this. I said, can I connect to an address? So I typed in an IP address, came right up. I'm like, So I can connect, I just can't resolve the names. So I open up 53 and we're good. So I basically blocked from 1 to 52, 54 to 79, 81 to 442, and 444 on. So it was so easy. I configured it on 1 in the Buffalo Wild Wings and more. Saved the configuration file. I did Edmond and Stillwater and did one other one, didn't I? Maybe only did 3. Yeah, I think I got 1 phone call and more right after I installed it. 1 call in Edmond. Never ever got a single call in Stillwater. So I felt guilty. All right, let's continue. Actually, that was more calling. Maybe it was Buffalo Wild Wings calling me after all these years. All right. So host names in DNS. We have an IP address, which is a number. Can you all remember IP addresses? I remember some.
The important ones.
Yeah. But still, those change too. So really, it's easy to remember names. Okay, like Google, Microsoft, whoever. Okay. Okay. People remember words better. So that's what all DNS does. Domain naming system resolves names to numbers. Okay. Actually, you know what? We have a little bit left. We're right. Let's stop here. Let's do DNS next time, because we'll be able to finish up next class period. So, all right. So let's stop here. Pick up on 48.